Well, start with Jen Dobry. Thank you all for, I hope I said that right. So before I start the talk, sort of wanted to say the inspiration for it. And if you don't understand what I say, just do what I did when I was in the taxi. Just smile, bardzo dobrze, I'll be happy. So the inspiration of the talk was I go to a lot of conferences all around Europe, and whether you go to a conference about TDD, continuous delivery, software craftsmanship, DDD, it always feels like, you go there, it's already a good idea, and you're bought in. You might learn something new, but you're already bought in, and not a lot of people talk about their failures, which I understand. You're quite conservative, you don't want to tell people your shit, and no one really wants to tell you how bad they were. But we're in a very unique industry where we learn from our failures, right? The motto for a long time was fail fast. We all wanted to fail fast. And no other industry has that. Like, you don't see, if you're a doctor and you're always failing, you're not a doctor for long. So I thought I'd start off with saying about my failure in my first job, which feels like a lifetime ago. But I remember I was given a server, and I said, I've got to deploy code to that, and that's my server. I can do whatever I want with it. And I was searching through the forums because I had this one thing that I couldn't get working. And I remember I looked at Stack Overflow, and someone said, oh, yeah, you've just got a Windows update, and it'll fix everything. And I look at my box, and it says, yeah, there's some updates that need to be installed. So it turns out I just need to restart the machine. I restart it. About 90 seconds later, there's a commotion behind me, and it turns out the sales director of the company was giving a demo on the box. So that didn't turn out very well. And that basically taught me if I'm ever going to give any sort of reboot to a machine or a service is going to be unavailable, give days and weeks in advance. So to start off with, we're going to talk about a lot of things today, right? We're going to talk about events, CQRS, DDD, commands, messages. There's so many interesting things to talk about. Microservices, Sama Elamin, I'm up there, I'm interesting to talk about. It's going to be quite a few things, and if you see a buzzword that perhaps should be there and isn't, please come find me at the party, and if I'm not too drunk, I'll add it. So I think you start off and ask yourself, why do people build monoliths? What makes them happen? We all know it's somewhat of a bad idea, so why do people do it? And the reason for that is because it's very difficult trying to break down and create little domains or little services. And most of the time, when you have an idea, you just want to test if it's worth it, see if it has business value, write it really quickly and ship it out, see if people use it. Scale isn't really a problem when you first start off. And it's kind of the reason why languages like PHP have become so popular over the past 10 years. People want to ship things out really quickly. And that's how we found ourselves. We had, we had a small application at some point, but when we saw people start using it, and it did give value, we were like, okay, just add this one little thing here, just add this one little thing here, and obviously it just grows, and that's how you sort of get there. So we basically had our situation was we had this massive application, thousands and thousands of lines of code. We had one database behind it. We quickly realized it doesn't really scale. You can't really version. We can't experiment with different things. There's no domain ownership. No one knows what everything does. There were like maybe 2 or 3 people that had a big overview of the system in a team of maybe 80 or 90 developers. So if one of them gets hit by a bus, we lose 30% of knowledge. So it was painful. I think that one of the most painful things was deployments, because we had really long, hard deployments where we'd be sitting in a Skype team because our offices were all over Europe. And we'd have an hour-long conversation, if the shortest would be, like we've got 20 or 30 tickets that need to be deployed. And we'd have like 50 people in the call, and it was really a deployment army. I remember there were calls where like 20 minutes in, I was like, let me check Facebook, see what my friends are doing this weekend. Because I just get bored, and it was just painful. It wasn't something that you really like doing. It's not something you wake up to and want to work with. So working with the code kind of felt like that. And it was just messy. It was, you know, you fix this one thing and then 3 other things break, and it was painful, basically. So we were like, you know what? So let's sort of fix this. We know it's a problem. When we go to the business and we say, the biggest mistake was we want to re-architect this thing. And when you go to a business person who is not very technically minded and say, we want to re-architect something, they're like, doesn't deliver business value, right? You know, this thing's making money, and you developers come in, you've only been here like a year or 2, and you're telling us we're doing it wrong. We've been here for 10 years, you don't know what you're talking about. So basically said no. Then we said, well, we could possibly deploy faster, we can deploy more. And they're like, what? We give you 20 or 30 tickets and you deploy every 2 weeks. You can do more? We're not pushing you hard enough. So either way, we failed, basically, trying to convince them. So we basically said, you know what, that's fine. If they're not going to let us do it, we're just going to do it behind their back. And it kind of like, it felt like very much like this. And the reason I have this slide here is because I remember back in uni, which again feels like a really long time ago, I had this really pretty girl going to come see me. And I lived with 5 students, all guys. And we were like, guys, we really need to clean this place up. And what happened was I swept everything under the rug, made it look clean. But once she started getting to know me, she realized it was all a lie. And that's pretty much how it was like at work. It was like we were trying to every time we had meetings about a new feature we want to develop, we'd say, okay, we're going to add a day or 2 to break this thing up. And it felt very underhanded. It felt like we were cheating, but it was the only way to move from where we were. We had the underlining acceptance that we had this massive application, but if we break them down, it will reduce the complexity. It will be easier to reason about, because it's easy to reason about an application that's maybe 1,000 lines of code than something that's 70 or 80,000. So that was the underlining thought, or the underlining goal that we wanted to do. We wanted to reduce the complexity, to make maintenance and develop new things easier. We looked at DDD, which is this book by Eric Evans. If you haven't read it, it's really useful. And it basically implies that you have to define your domain, define the parts of the business. And domains are not really technical. They're your business components, like, you know, payments is a domain, your customer services is a domain, warehouse is a domain, and accounts are different than finance. That's different, 2 different domains. So we had to, we knew our application, and we knew that, you know, it has different parts of the domain. We needed to identify them. We said we're going to use PubSub. For those of you who don't know what PubSub is, it's basically a publisher would publish a message like order placed or order created if you're in an e-commerce website. And you've got this message goes into a bus or wherever, and it basically says, okay, who wants to listen to order placed? And we'll have a component that says, okay, I listen to order placed. I hear it. I'm going to be like, okay, I'm going to take payment. And then I publish payment captured. And then so on. Another component says, okay, I heard payment captured. Now I have to check if we have stock to deliver it, and so on. It was a nice, in theory, it worked really well, and it would have worked for us in theory. So the first thing we said was, we have this application. We know this part is payment. We know this part is customer service that speaks to the customer and sends email. We know this part is part of the warehouse. So let's just identify our domains. Let's identify our bounded contexts, and to find out which part needs to be broken up or taken out of the monolith first. We quickly realized that because of the shared database, everywhere in the application, something would be like, actually, I need to change these things, but this thing is over there, I'm going to change it as well, because, you know, it's all centralized. You can change wherever you want. So we're gonna define an interface for you to change whatever you want. But for you to change this particular record, you have to go through this interface. And that basically allowed us to say, put like a barrier and say, anything you want to change in the database goes through this interface. And that basically moved the database away and allowed this service to say, okay, first of all, I'm going to use this database, but maybe later on, I could use, a NoSQL, SQL, MySQL, text files even if you want. So that basically was one of the biggest pains when people want to break down a monolith. It's the shared database. And that's one thing that really works well. You define this interface and everything that changes that. You don't access the database directly. So we quickly found out that once we have these services deployed in production, and because of the asynchronous nature of messaging, things can arrive out of order. So, for example, you could say you're a service and you're listening to order placed, but actually you hear payment captured, but you don't know anything about the fact that order placed was made. And then maybe 2 microseconds later, you hear order placed. So things arrive out of order. And this is something that we never really had to worry about because of the monolithic application. It was all synchronous. So it wasn't a problem we needed to have. So we'd have situations where in production, another failure of mine, I remember in this company, was I had to write a service that goes to the customer and says, you placed an order, but you haven't paid for it in X amount of hours or X amount of weeks. Send a gentle reminder to say, please pay for it, or we're going to sort of lose your stock and give it to someone else. So, we sat down with the business orders and the QAs and said, okay, let's derive a story. Someone places an order, doesn't pay for it in X amount of time, send them a reminder. It's very simple. But then, because the messages arrived out of order, the application says, I heard order placed, but never heard payment captured because it arrived, X amount of microseconds earlier. So I'm just going to send the email. So the behavior of the system was correct. But customers were getting emails saying you haven't paid when they have a PayPal confirmation that they have. So they're on the phone to customer service saying, shoot your developers, they're horrible, useless people. And it's really bad user experience. So every single time we'd have a problem, we'd go to our account managers or customer services or domain experts or stakeholders and say, no, it's because of a race hazard. It's because of a race hazard. It's because of a race hazard. To the point where they were like, say it again, we're about to shoot you. It's so frustrating for them because they were like, what are you guys doing? It was fine before you guys joined, and now we're having all sorts of problems that we'd never heard about. And they lost faith in us. They basically did not believe what we're saying because they didn't think we had the competence because we're coming across these problems that they never really saw before. That basically really just realized that testing is actually very difficult. It's very hard to test hundreds of services in your, no matter how powerful your machine is, you can't run 30 or 40 or 50 services, let alone hundreds. And also, these things that only happen in production that never happen in your QA environment because you're not on the same level of load. You don't put it under the same level of stress. And you don't have as many issues that you only see when you have loads of messages flying around. So yeah, testing was hard. And to solve that, what we did was we tried to have an integration environment to where we push all our changes to, and we try to put load through it to try and replicate production in the best possible way. So that was one way we tried and fixed that. But then we realized, you know what, now that we've got teams around set of contexts, deployments are really hard because one team would be like, I'm going to use Rake, or I'm going to use Make, or I'm going to use PowerShell, or I'm going to use, and they start just saying, well, we have autonomy, right? We've got these set of services, we own them, we can do whatever we want. But then deploying them became really difficult because if you have to work across boundaries, you have to know how the other team deploys. So getting consistency was quite difficult, and it's something we had to learn very, very quickly because of the pain. So yeah, once we solved that and we said, okay, this is how everyone's going to deploy their things, it became somewhat easier. So the next biggest pain we had is we never really had any domain ownership. We didn't know who's responsible for what. If someone needed a feature, they're like, who owns this? Is it these guys, these sets of this context? Is it this context? Is it this context? And the reason for that is because it was never defined by the business in the first place. So that was one pain, but I think in hindsight, one of the biggest pains is the fact that we didn't have a common language or ubiquitous language between us. So the reason for that is the evolution of the code changed during the time. A good example of that is we'd have that when you're speaking to the business owners, they'd be like, okay, we would like a saved card service where users can save their cards so they can pay easily in future. But then when you look at the code, it says tokenized authorization service. And it didn't make sense. And developers and QAs had to work as translators. So they'd go and speak to the business in one language, but then they'd have to come into the code and try to translate that. And that context switching is actually very painful. It's very time consuming. So that's something you should look at in your work. Is the language you use with people when you're describing your features what you're actually coding in? And if it's not, then there's definitely a problem there. But we tried to identify the boundaries, and it helped us find these problems really quickly, and it made it very clear that the code doesn't reflect what we talk. So then it was like, we've got so many issues happening in production. People were very, very fearful of change. Like teams were like the business is blaming us, but it's that team's problem. And it became very much a blame culture, where we were really worried about how you make changes. So it became very strict. Code reviews became extremely strict. And for the smallest thing, you'd reject it. You're like, no, you used a curly brace here. It should be formatted differently. And code reviews became a gateway to say, we're going to use code reviews to stop issues happening in production. And when you've got issues happening a lot, that's what you fall back in. You're like, actually, I'm going to be a bit more resistant to change because I don't want issues to happen. Stability is very important to the business. But the problem with that is you're reducing your efficiency. Code reviews are meant to help share knowledge, not to stop breakages. So in my team, we sort of went with something completely mental and said, you know what, we're just going to accept all code reviews. Sorry, we're going to accept all pull requests. And to the other teams, they were like, they're stupid, they're going to cause problems. We just said, like, if it passes the build, then we're going to accept it. We're just going to merge it. And surprisingly, that caused quite a unique situation where people were like, if they're going to merge my pull request, I need to make sure it's tested. So they kept on adding more tests because they're fearful of their change causing issues. And it basically became very much like an open source culture, which in an internal company it is, right? Any team can use your components. Any team can use your whatever packages that you have. So you should be more accepting. And if you have an open source project and you're like, actually, I'm going to be very strict with my pull request, you're not going to go very far with that open source project. So that's how the mentality we did. And it was surprising. Like now we're like so accepting of these PRs that we're getting more and more tests added around them, and we're getting more confidence in things that are being sent through. So now that we've got all these services running, we had the problem of how do you know if something's up, right? How do we know if something's alive, something's responding? How do we know that an application can subscribe to what it's supposed to subscribe to, listen to what messages it's supposed to, send to what message it's supposed to? So when you have one massive application, it's fine. It's very quickly you can tell if it's working here, it's definitely going to be working there. And having unit tests, we had problems that would not have been solved by unit tests. For example, an application comes up, it comes up fine, but then when it tries to subscribe to an endpoint or subscribe to something, a message that it cares about, it couldn't find it. A unit test would not have helped us solve that particular problem. So we had to have monitoring in place where it was, are you healthy? It's a health check. Are you healthy? Are you able to do what you're supposed to be able to do? And the more services that we had, the more monitoring we had to put in place. And that was a problem we didn't really envisage, but we sort of had to put in because of the pain. So the sort of takeaway to what we learned about making things smaller is you're not making things simpler. You're not making things easy. Microservices are a really hot topic right now, and everyone thinks it's going to be a silver bullet. But Michael Feathers had a very brilliant quote, and I'm quoting it. It's, when you make things smaller, you're not wiping away the complexity. You're pushing it further onto the interactions of the components. So it becomes very difficult for a new person coming in and says, okay, I'm only in charge of this context. I know when things come in, and I know when things come out, and I know what I have to do with these messages. But how does it fit into the overall user flow, overall user journey? How do I know my change is making what I expect it to do? And it was very difficult for people who are moving across teams or new joiners to the team to get the big picture, to get the understanding of what's happening throughout the system. And it's because the boundaries are less, but the communication between them is sort of hidden. It's not very explicit. So we had a massive retrospective about this journey we went through. And the first thing we should have done is, sat the business down and we said, this application will die in 6 months. Then they were like, no, you're idiots. How will it die? And you're like, well, how many orders are you doing at the moment? And they'll say X amount, hundreds, thousands, or millions, or whatever. And you say, well, how many orders are you expecting in 6 to 8 to 12 months? And they should have these numbers. And they'll be like, well, this amount. And you're like, well, this system can't handle it, and here's why. And we didn't do that. We went to the business saying we need to architect because we're feeling the pain. We didn't give it business value. So a good experiment, a good thing to do is to sit them down and show them these details. But it's a problem you need to communicate. And in the end, you have meetings where they're just fighting. You're like, no, we have this particular thing that's more important. And the business, where the product owners or domain experts fighting. I can't remember the amount of times I was just like this guy, where I was like, I'm ready to die here because they don't understand the actual problem. But when you get all the business people involved outside tech, and you have to facilitate these conversations, you show them what's important. And a good thing to look up is events storming. So the idea is to set up, put them all in the meeting room and put your events in the board, the main events that happen in your user journey. So things like order placed, payment captured, order fulfilled, shipped to warehouse, these things, put them in the board. And then you put commands that cause these events to happen. What happened to make these events happen? So payment captured must have happened because someone sent a capture payment command. And it gets them to sort of model their whole life cycle. And you keep tech, you keep all your developers and QAs outside these meetings. They should just be like silent chickens, not seeing anything, not communicating at all. Just let the business define their domain. And then you come in and you look at what they think their business is and how does it reflect in your code and how does it reflect in your tests. Does it match up? And it's surprising the amount of times that it isn't. It doesn't at all. So you need to get the business involved to say, actually, we do have a problem, and it will be a problem, and it's going to be a threat. Whether it's a threat now or there's a new company that's coming in, that's shipping faster, cheaper, because they've redefined their model or they've redefined their domain. Another question is data duplication. Is data duplication bad? And this is something I'm really proud of. Normally, when people first meet me, saying, what a loud idiot, he doesn't know what he's talking about. So the first thing that I got quoted on when I joined the company was, I prefer data duplication over code duplication because it basically decouples. I want to decouple. I don't care if I have this data here that seems similar to this particular data here. Because, for example, like in finance, an account might mean something completely different than in accounts. Like an order and a user is completely different for accounts and finance. And the reason for that is the domain object is different. The definition of an order to the warehouse is what am I actually going to ship? What do I need to put in this box that goes? The definition of an order to finance is how many things, what do I have to charge them for? You know, delivery fees and you know, user fees and card fees. So they're different meanings. So at the first, it seems very similar, but when you actually look at it, they're very, very different. So I don't think data duplication is a bad thing. The business cares about, you know, whether the data is consistent, is it not stale, and so on and so forth. But once you explain what eventual consistency is, then you realize, you know, this particular thing here means something completely different here. For example, the order. The next is an orchestration layer. It would have been really useful if we had a layer that said, okay, I'm going to be working like the old telephony service people, where I'm going to hear this one thing, and I'm going to tell it, okay, you go here, and you do whatever you want. For example, I hear order placed, and I know what the next step or the next thing in the flow of the user. That would have helped people joining in that's new to say, actually, I know what the next steps, I know what the journey is because it's in this orchestration layer. And it doesn't need to do anything but forward. All it's doing is forwarding. But at least you have one centralized place where you know your flow. And it really needs to be very light. It just needs to be directing things and not actually doing things. I can't stress that enough. You don't want your orchestration layer to be doing stuff. You want it shipped off to the bounded context that actually is doing the stuff. So having this done what's next, done what's next, done what's next makes it quite simple to understand your flow when you've got a microservices architecture that sort of is hundreds and hundreds of services. You don't have to understand where everything is. You just need to understand what's next. So this might actually annoy a few of you, so I was a bit worried about adding it. But part of the reason of the business finally getting buy-in in this is the fact that we added metrics. We added metrics to help us identify when things are happening. So because of all these services pushing out logs and stats and points, we were able to say, okay, how many orders are we making a minute? How many user signups? How many searches have been made in the past minute? And it basically gave us confidence. It gave us confidence if we release something, how much it affects the user journey, how much it affects conversion, how much it affects the overall feeling. And you know, if we were to break something, we immediately have an alert that wakes you up in the middle of the night saying, you know, this thing's broken. An acceptance test would only run once, and I hate to be the person who is on the call saying, actually, that thing passed just before deployment. Here, you can see the report. So the self-monitoring sort of help gave us a little bit of confidence. So it became, we started doing tests in production, which is quite amazing because it's a completely change in mentality. And I think this is, you know, microservices and DevOps, it is a change in culture in the company. Because the confidence that the business users felt when they were like on the phone saying, there's something wrong, and we're like, yes, we're aware that there's something wrong. And if you look at the board on the graph that we showed you, which are showing metrics of what's happening in your platform, it gave them a lot of confidence. Like everyone had visibility in exactly how well the health of the system were. It gave them, you know, when they push a change, when they push an idea or something that they thought might help, they immediately know how it affected the customer's experience. And these business metrics basically gave them more confidence in us. You know, it felt very good for them to say, you know, there's a problem, but we know that you're already aware. That basically made them feel like we shouldn't be shot like they thought before. So the metrics also gave developers a lot of freedom because you know, we're in a team of 5 or 6, and that's about how the size of the teams were. You know, there was like maybe 12 teams, and all of them about 5 or 6 people. You basically are given the freedom to do whatever you want as long as it achieves the behavior. The business doesn't care about the underlying technology. And that basically excites a lot of developers and QAs because, you know, you could do whatever you want as long as you achieve the feature. Right? You don't have to stick to a certain language. You don't have to stick to a certain technology. You can do whatever you want. But at the same time, it's a double-edged sword because you could be in a team and then you realize this person's written it in Golang, or this person's written in F#, this person's written in .NET, this service is written in Java. So it has to be accepted within the team. And when you have a smaller team, it's easier to agree on what you're going to use and what you're not going to use. And it gave them a lot of excitement. You're like, actually, if this thing I don't understand what it does, or I don't agree with the way it's written, all I can do is just rewrite it, right? It shouldn't take that long because this thing is really simple and it does this one little thing. So it can be dangerous, but it has to be the culture of the team to sort of accept this change and change it however way you want. So what does the future hold? I think Docker is really powerful. I think it's came at a very right time. And for those of you who don't know what Docker is, it basically allows you to separate the operating system and have your application in one little container and deploy multiple. A lot of people who are currently in the cloud, what they do is deploy their applications onto EC2 instances, which are Amazon's version of virtual machines. Azure have the same virtual machines. And there's loads of cloud infrastructures where you deploy an application and it's in one VM. But the problem is, the more services you have or the more applications you have, the more service you have to have, the more virtual machines you have to have. And that adds an overhead because there are more network hops between them. So Docker allows you to sort of put it all in one container and you can have multiple services in one machine. So yeah, if you're interested in things other than Java, I wrote a blog post on how to use that with AWS, and they give you a free user trial, so you're welcome to do that. So my sort of leaving note is the next time you have to write a feature, try and run it as a service. Obviously, your infrastructure needs to allow you to actually write these little services and allow you to deploy them, but try and write it and break it down. But invariably, the question comes into how do you define a microservice? And I don't think there's been a definition. I don't think lines of code is a good definition because it shouldn't be. I think, and personally, it's my personal opinion, I think it should be something that you can rewrite. Anything that you can rewrite in a week can be defined as a microservice, in my opinion, because if you don't like it, you can just rewrite it and deploy it. And I think that's sort of, it's not a hard and fast rule, but that's something I try and stick to. If I don't like it, I try and rewrite it. And if it's longer than a week, then it could be a problem. If you feel like your application is easier to understand, just remember that, that if you have a 200 or 300,000 lines of code application, having 80 or 90,000 tests are not going to help you understand what that application does. So try and build your own service and sort of specify what it does. And in terms of what it does, I think it should be a business component. For example, anyone who's done like a tutorial on learning a new language would have probably seen like the tax calculator or some sort of calculator where it takes in operators and two numbers, whether it's two numbers adding or two numbers subtracting and so on. I wouldn't write a microservice to do the addition and subtraction. I would write one that takes in these parameters. So it should be a business component, a business unit. So you have to look at what the business is trying to achieve and try and map that to a service. And off to any questions. Okay, thank you.